कौन सा चैप्टर दिए इन लोग? एक प्रिया ने भेजी थी मेरे
6,
को।
9, 11 and 14, I think. 6, 9, 11 and 14. You have something like that.
हम्म,
कितना करेंगे?
अब आप
बहुत
दिस टाइम
कुछ है।
पता नहीं कि क्या करेंगे। एटलीस्ट लास्ट टाइम तो बहुत अच्छा था इसके पहले देखने से।
6, 9, 11 and 12. These are the
डिस्क्रिप्टिव।
units. No, not 12. I think it will be 14. Do you have the list?
आई एम जस्ट चेकिंग दैट वन, आई एम फाइंडिंग इट। आई गो ना।
See, I have a merged version of algorithm.
कहाँ पे आया है ये? ड्राइव में भेजी है करके बोली थी। Also did not check.
So, see, decrease and conquer. They have not mentioned about divide and conquer. To me, that is more important than decrease and conquer. So we have been given with this part, these
हम्म,
units, 6, 9. So
वही देखी
6,
थी मैंने भी।
uh,
हाँ।
unit 6 is about decrease and conquer. Anyway,
हम्म,
first we will try to cover this unit. Let's see. First, there is insertion sort. You
हम्म,
know, there are many sorting algorithms, like insertion sort, quick sort,
मर्ज सॉर्ट,
merge
बबल
sort, bubble
सॉर्ट।
sort, heap sort, selection
हम्म,
sorts are there. Like insertion sort is also a kind of sorting algorithm. Okay.
हम्म,
So see, in this subject, they
हम्म,
can provide
हम्म,
the questions in two different form.
हम्म,
Okay. In one kind of form, they may ask you to
हम्म,
write the algorithm. Okay. Write the
हम्म,
algorithm. Okay.
हम्म,
Along with the implementation of coding in any of the programming language, either in C,
हम्म,
C++, Java, they will
हम्म,
mention that the programming language.
हम्म,
So with algorithm, questions may be given in that way with algorithm. Say one kind of questions will be write algo
हम्म,
with or without code.
कोडिंग।
Code means code in
हम्म,
any programming language. Okay.
हम्म,
The other kind of question they may give some problems.
हम्म,
Okay.
हम्म,
Solution to problems like mathematics.
हम्म,
Okay. Like it is like mathematics.
हम्म,
Last semester we did some mathematical problem like assignment problems and
हम्म,
किए थे ना हम लोग. We did that
हम्म,
northwest corner problem. The
यस यस, दैट
similar,
जॉब।
yeah, job
हम्म,
scheduling problem. The similar kind of
हम्म,
thing can be given in this question. Okay. See, these the topic of this algorithm. Okay, this
हम्म,
subject. Many of the topic from this subject are included in another very famous subject that is called OR, operational research. This
हम्म,
subject is there in 3-year MCA course in many university curriculum. Okay,
हम्म,
operational research or operation research, and it is also a subject from MBA. Okay, MBA people do these are some mathematical calculations. Okay,
Mm-hmm.
for which algorithmic part has been
Mm,
given in this subject algorithm design analysis and algorithm. Okay,
mm,
so to me, I guess that they may give you a few simple type of algo, writing algo, and maybe two writing algo, okay, with or
mm,
without code, and maybe four problems. I don't know. I'm just guessing. Okay, I
mm,
don't know. I'm just guessing. Okay, so this solution to problems, if they give you to write the algo, then it will not be a very problem because
mm,
if you collect all the algos from net or book or anywhere, then you can
mm,
just remember the algo and write it, or you have some other processes of writing that algo. Means a textual format in textual format. Okay,
okay.
but if it is given in this part, means the solution to problems. So they
Mm,
will give you a problem like mathematical
mm,
problem. They will give you a problem and you have to find out the solution. Okay,
mhm,
then that will be a means a very big task. So you have to know the process and the operations actually how the algorithm is working. Okay,
mhm.
in
Do you
operational
think they will give for
operation
this
research,
thing
that is the main thing
for
how the
5 mark?
algorithm is actually working. Yes,
Mm.
please.
This they will give for 5 mark, that one
Ah,
operational
that
one.
5 marks, obviously the
Mm-hmm.
descriptive part. I'm not considering anything from MCQ part. MCQ is, it is a vast subject. They can put MCQs from anywhere. Okay, uh, but only the descriptive part. If you think about the descriptive part, so
No,
the
I was just asking for 5 mark. They will ask for what you said, the other one, the solution to a problem.
yes, 5 marks. Some problems are there. You will find that 5 marks is very less to
Mm-hmm.
find the solution. It's a very big kind of solution. Okay, so anyway, as much you can, you have to know the portions. So like this,
Mm-hmm.
the insertion chart. Okay, let's suppose insertion chart. They may ask you to write the algo of insertion chart. Okay, they may ask you to write the algo of insertion chart and write a suitable program for the insertion chart. That will be a very easy task. Okay, but if they ask you to apply the insertion chart like this, okay, apply the insertion chart on a given set of array,
Values.
then
Mm,
that will be a problem. Okay, you have
mm,
to show the different steps and a
mm,
thing like that. Okay,
mm-hmm.
so I want to just today I want to just demonstrate you how to sorry, how to do that, how to
Mm,
solve the problem. Okay,
mm.
I know that it is not possible to cover even these 4 units operation. It will take a huge time to cover all the topics from this.
Completely.
Okay, but what can we do else? Anyway, uh, initially we were discussed about the time complexity analysis and many things about, I think, this algo. No, we have that
Mm.
recordings over there, so we were not able to continue in that way.
Yes.
Okay, so should I demonstrate in insertion chart?
Mm. Yes, yes.
See, insertion chart,
Mm.
if you, if I write, let me write a simple code for that, not code, It's
Hmm.
for say j is equal to
Hmm.
2 to n. Suppose there is an array. Okay.
Hmm.
Suppose there is an array. Say int.
Hmm.
There is an array. Say A is the array and it contains n elements. Okay.
Hmm.
So for that you write an algo.
Hmm.
I'm taking a loop for j is
Hmm.
equal to 2 to n, which will iterate from 2 to n. Okay.
2 to n. Hmm.
Then I'm taking a variable say key is equal to a of j. I'm storing what? The jth element of
A
a.
in key. Hmm.
Jth element of a I'm storing in key. Okay.
Hmm.
After that, I'm taking a variable say I
Hmm.
and set it with the value of j minus 1.
Hmm.
Okay. I'm
Hmm.
just formulating it. I'm just demonstrating the
Hmm.
algorithm first, then how to go with the process I will show you.
Hmm.
Here I am again taking a loop while
Hmm.
your I is greater than 0
Hmm.
and a of j means the jth element is
Hmm.
greater than key. So this is a loop, while loop. It will iterate until I
The
reaches to
I value
0
is
and
greater than 0
with that
and
jth
A of
element is greater
is
than key. Okay.
key.
Then what you have to do? You have to do I plus 1. Okay. A of I. So what you are doing here? You are shifting the ith element
To I
into
plus
the
1
next place
position.
in
Hmm.
the I plus 1 position. So you are
Hmm.
shifting the ith element to the next place.
Hmm.
Okay. And after doing that, what you will do? You will decrement the value for I. In that way, if you write the algorithm, you will easily remember. Okay. So
Hmm.
while will be end here, after ending the while, what you will do? You will insert at I plus 1 position the
The
value
new
key.
element.
Key. That key you that jth element was
Hmm.
stored in key. Now you are placing that key here. Okay.
Hmm.
So this loop will iterate, and this is simple. This is very this completes your insertion short. Okay.
Hmm.
Now let me show you an example. Say I am taking this array. We can
Hmm.
take their array, na?
Yes.
Just print screen and copy that part only. How to do it? How to process the algorithm along with this
Well,
given
set of
problem?
values.
Okay.
Hmm.
So if they ask you to write the algorithm for insertion sort, that is enough. With that, you have to write the code in Java or in C or in C++, whatever they ask for. Okay, so that is a code. That will be a code. Okay, and the code should means the code inside the code you will process. You will go with the implementation. Say suppose you are taking Java. Okay,
Hmm.
so they are inside main, you do all the tasks. Don't go for the object oriented approach means creating a class, creating objects of it. No requirement of that. Okay.
Hmm.
Rather you means
Procedural oriented.
according to me you just write a function. Okay.
Hmm.
You just write a function and that will be a very much okay with function
Okay,
FUNC
got it.
TI only the
Yes, yes,
function.
agreed.
You do not
Hmm.
go for the implementation taking input in the array. No, that is a waste of time. You just go write a function. Okay, just convert this algorithm to a respective C++ or Java function or Python function. That's all. Fine. Okay. Now the second part asks to solve problem. Okay, they may give you an array like that and ask you to solve according to insertion sort.
Insertion sort.
Okay, so according to insertion sort, or for going in this way for any algorithm is also called dry run.
Ah.
Okay, so dry run. So in dry run, one essential part is variable listing. If you can do, you can put a variable listing for that. Now, what is a variable listing? Variable listing, you have to consider all the variables used in this algorithm. Okay. So what are
Mm-hmm.
the algorithm? What are the variables you have used here?
Mm.
Say n. Next,
Then
you have
J,
j.
I,
You have key.
key, and I.
Key. After that, you have I, and
That's
inside variable list table, you must put this condition. Okay, I greater
mm.
than 0, this condition. So I greater than 0
And
and
J greater than key.
a of j, a of
Mm.
j greater
Greater
than
than key.
key. Okay,
Mm.
so that is a table.
Mm.
This table will also help you to go the diagram condition. So this is your 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so what is the value of n? Value of n will be 8. You may ask
Mm.
me, you are not taking the first element as 0. You can take it as a 0. Okay,
If I take 0, that last element will be, nth element will be
yeah.
7.
If you take 0, okay,
Mm.
if you take it as 0, then this j equal to 2 will be j equal to 1. You have
Mm.
to start from the second position in this loop. Okay, this. Okay, so I am taking it starting from 1, 2, 3, 4, like that. Okay, so now proceed with that. So j equal to 2. So what I write here, j is equal to 2. Okay, so I
Mm.
am inside this loop. Okay, so when I put j equal to 2, I am inside this loop. Now inside this loop I am at this line. So key is equal to aj. Now what is key? Key is this variable.
If
We
J
have to
is
put the jth
3.
element, means j is 2. So a2 is this na.
3.
So we have to
Mm.
put 3 here.
Mm.
Now tell me, if I put 3 here, can I say that this position becomes empty? Just for the sake of the algorithm, you think that this position
Mm.
becomes empty because we have already saved the content of jth element here.
A,
Na?
in K. Mm.
So here there is a gap. Okay, you have to fill up this gap accordingly.
Mm.
Okay, how? See here, proceed.
I is equal
I is
to J.
equal to j minus 1. So what is your I will be your
I will be 1.
j minus 1, means 2 minus 1 means 1. Okay,
Mm.
right?
Mm.
Now here you are here.
Condition.
Now check the condition. What is the value of I? That is 1 greater than 0. And what is the value of aj? This is aj greater than k. What is the value of aj?
AJ is 2. 2. It was 3. Value of AJ is 3.
Just a minute. This will not be j. This will be I. That's why I am thinking. This will be your I. Okay. This
Mm.
will be your I. This will be your I. Okay. So AI. What is the value of AI? I
AI
is
will
your one, means this.
4 will be the
So 4 is greater than key means
greater
3.
than 3.
So tell me, is it true or false?
Condition is true.
Condition is true. If the condition is true, then these two statement will
Interchange
be
should
execute.
happen.
So
Mm.
AI plus 1 will contain now ith element.
Mm.
So AI plus 1
2
means
will
this
be
position. this position
Will contain 4.
contain ai means 4. So can I say that this element moves in this direction? Can I say?
Hmm. Yes.
Okay, okay, okay. Now see, if that take place, then I can say that 4 comes here, 4 comes here, okay, and the gap
Hmm.
now becomes here. So this gap
Hmm.
is going in this direction, and the data
Hmm.
is coming in this direction. No?
Hmm.
So you are inserting this 4 in this gap, right?
Hmm.
That's why it
Hmm.
is called insertion chart. Okay,
Hmm.
okay. After that, what you have to do? Check. After that, what you have to do? You
Have
were
to
in this
replace
line.
fill this gap. Key value should be changed
No,
to
here
while.
you were in this line. Okay.
Okay.
Now you are in this line. I
I
is
should
equal to I
decrement
minus
it.
1. So you should
Hmm.
decrement I. So I will now become 0.
0.
Now after that you have to iterate to the while loop. Okay.
Hmm.
Because it is under while. So you have to iterate here.
Okay, this is key replacing the keys outside the while loop.
Yeah. This is outside the while loop. See here. Whatever they are inside the while loop, that is here.
Only
Right
the two
written here.
statements.
Okay.
Hmm.
So this is outside while.
Hmm.
So you have to check 0 greater than 0. 0 greater than 0, and this is false, so
From
I am not required
false
to
is not.
calculate
Check
this
that.
part. Okay, so it is coming out of the loop. Now you are at
Hmm.
this line, ai plus 1. What is the value of I?
Hmm.
0. So what is
Hmm.
ai plus 1? That is a1.
1.
So at a1 position you have to place the value of key. Means what is there in key?
Hmm. That
3.
is 3.
So you have to place 3 here, right? You have to
Hmm.
place 3 here. Okay, are you getting the thing?
Yeah, yeah.
Okay, now see, among these two, you have already done. You have made a sorting order between these two.
Hmm.
Okay, now what you have to do? You have to move to the next part.
J loop again.
Okay, so give a line here, then increment the value of j. So j will now become 3. Okay, after that, again you are at this line, key is equal to aj. Means now what is aj? J is here now. Okay, your j is here.
So key will be 2.
So key will be 2. So I can
Hmm.
say that this place now becomes empty. Okay.
Hmm.
Now what will be the next line? I is equal to j minus 1. So what will be the value of I? I will be j minus 1. That means I will be 2. That means you are
2.
placing I here. Okay. One place before j. Okay.
Hmm.
Now you are checking while loop. Again, I greater than 0. Okay. Is I greater than 0? Obviously I
Yes.
is greater than 0. So that is true. And I'm not writing the whole syntax. And then ai means what? 4.
Hmm.
4 is greater than key.
Hmm.
Key means what? 2. So 4 greater than 2, again true, right? So it will go inside the for
Hmm.
loop. So what it will do? ai plus 1 equal
While
to
loop.
ai means this item will move here. Okay, if this item is moving here, then what I have to
Hmm.
write? I have to write
3
I have to write
space will
4
be
here.
created. Hmm.
I have to write 4 here. I have to write 4 here, and this place becomes empty.
Hmm.
Okay,
Empty.
this place becomes
Hmm.
empty. I was there. I was there. Now follow the next line. I is equal to I minus 1 means I will become 1. Na?
That will be 1.
That means I is
Hmm.
moving in this direction. Okay.
Hmm.
Now again you are at while condition. So I is greater than 0. Again see I is your greater
Yes.
than 0.
Condition
That
is
is
true.
true. And
And
ai means 3. 3 is greater than
3.
key is 2. No? The 3
Uh,
is greater than 2. Again
so it
true.
is also true.
So again it will come inside the while loop. So what it will do?
Hmm.
It will
It will
shift
replace.
this one. Okay.
Hmm.
See here. So it will be your 4, it will be your 3, and the gap is now at this position. Okay.
First position. Hmm.
So the next point is decrement the value of I. Decrement the value of I means it will go 0. I means I was there. So I now move in this position, right?
Hmm.
Now if I is your 0, so this become false.
False.
The loop terminates and it will come
Both.
to this line ai plus 1. Ai plus 1 means this place, na? I is
Hmm.
0, so 0 plus 1 means this is the one place. So here you have to put the key, means 2 will be placed here. See, up to this it is sorted. Are you getting the thing?
Hmm.
Tell me, is it okay?
Yeah.
So this is the way how you have to show the process of insertion sort. Means you have to complete all these tasks. You have to complete all these tasks, okay, until the array becomes
Getting
fully
started.
sorted. Okay.
Hmm.
So after you sort all these things, it will look like this. Okay.
Hmm.
So that is the process you have to maintain. Okay.
Okay.
You just do the practice today
Hmm.
just by seeing the video again. Okay.
Hmm.
And process in this direction. Okay. Now why it is called insertion sort? See, you have applied insertion sort in your daily life almost every
Hmm.
day. Okay. Like when you are arranging some currency note in your purse or in your hand, then you are following the insertion sort. Okay. The card players, those players when take a
Hmm.
deck and arrange the card in their hand,
Withdraw
na,
the card and they insert the card.
they follow the process of insertion sort. If you follow them, how they are arranging their cards in the deck, then you will
Hmm.
find that they are making, means they are shifting their cards with one finger, na? And
Hmm.
while finding a proper place to insert a card, they put that card
Hmm.
there. So that is a process of insertion sort. Okay. So that was our insertion sort. And since this unit is included in their descriptive part as per the faculty, so this is the simplest algorithm among all the 4 units, and is
Hmm.
a very huge chance of giving anything: algorithm, code, and operation. Okay.
Okay.
So I'm not completing the whole operation, it will take too much of time.
No
You
problem.
can
Not
always do
required.
that.
This
Okay.
one or two steps is enough for me. I can continue with
Okay,
this.
okay, okay, okay. So coming to the next topic, what is it? What is it? DFS. Okay, DFS and BFS. Always these two are important. Even in data
Ah,
structure,
this so
even
many questions they had given no on this.
and this is
Yes, yes.
also the simplest one. Okay, DFS and BFS. These are the two ways of traversing a graph. Okay,
Mm-hmm.
DFS, depth first search and breadth first search. Tell me, do you know DFS and BFS?
Mm-hmm.
Don't know. Okay, so take an example so that we can do it fast. I do not like this graph. Don't they have any other graph here? This is a tree, although we can put DFS. A tree is also a graph, you know.
Ah.
Uh, Image of graph for DFS. Acha, DFS and VFS are the two ways to traverse a graph, you know. How to traverse a graph?
Mm-hmm.
That is a DFS and BFS. We,
Mm.
this is a complicated graph. We can take it always. No, I am interested in non-directed graph because I find this one is non-directed graph. I hope if they give to traverse a graph in DFS, they will also give you a non-directed one, a normal graph, not directed graph. Okay,
Mm.
so take this one, copy the image. Okay. गूगल से इमेज कॉपी करना आजकल बहुत ही
अब
टफ हो
बहुत
गया.
डिफिकल्ट हो गया मीन्स ये नेस्टेड हो गया बहुत सारा इसमें अंदर 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 जाता है
कौन सा?
अल्टीमेटली वो इमेज ही नहीं देते
हाँ वही, मतलब copy image. Why it is not happening? We always have some other ways of doing things. Do you know इसीलिए Google appointed Pichai. Pichai is there na at Google.
yeah he is there
That's why. Okay, Indians are very efficient in copying the things. So how
so
to
he
stop?
they wanted to block
Yeah,
this
how to
copying
stop the efficiency of copying? That's why I appoint an Indian for that purpose. Anyway, so let's consider this graph. Okay, so DFS and VFS are the two ways of means traversing a graph. Okay, let me copy this one and paste.
but
So
always picture can fail because the Indians are too good in copying
no, since Pichai is also an Indian, I believe that he will not tell everything to Google. Okay, so he is keeping always a part
for
open.
India. Mm.
Anyway, see here, the DFS and BFS are, I'm right showing it parallelly, huh? So that
Mm.
you can get the idea. It's very easy.
Mm.
Traversing means what? You have to move,
Traveling from one
travel
node to
from one
each
node.
node.
So
Mm.
you must consider that
At
each and
least
every
once we have
node,
to,
each
at
and
least
every node
once,
must be visited. Okay. So
visited once,
DFS
at least
is
once.
DFS is breadth first search. Okay. Hey, sorry,
Mm.
depth first search. So
Mm.
to perform depth first search, you need a
Mm.
stack.
Okay.
Write a stack. So this is a stack.
Mm-hmm.
To perform BFS, you need a queue.
Mm-hmm.
This is the main difference between these two. Okay.
Okay.
Now you follow the same rule.
Mm.
You follow the same rule for DFS with the stack. Whatever the result you will have, that is DFS. You follow the same rule for BFS with the queue. Okay.
Mm.
The traversing rule follow with queue. You will got the
Mm.
result in BFS. Okay. And one more thing I can say you that there may be multiple result. Okay, multiple results of DFS and BFS. Let's move with this example and we will explain. So DFS,
Mm.
always you have to select a starting point. Currently we are selecting the starting point here. Okay, so this will also be the starting point
Anywhere
here.
we can take, or it should be a parent node.
It's not like parent. Okay, since this is not a tree, this is a graph, there is no
Mm.
parent This is nothing, and also this is an undirected graph. So hardly you will have, hardly you can identify which one is parent or which one is a child. Okay.
Correct. Correct.
So if it is a directed graph, then you should follow, then you should start with a vertex which have in degree is equal to 0.
Mm,
Okay. In that way you can always start. Okay. Anyway, the start is not a factor. The main
mm,
factor is you have to traverse, you have to reach every node. Okay, every node
mm,
will be there in your result. Okay. Now let's see.
mm,
If we start from A, just
mm,
when you are when you are at any
mm,
node, that means you are visiting that node and that node is processed. Okay. So when you are
mm,
A, just put it here A. Put it here A. Okay.
mm,
You put it here A. I am guessing that, not guessing, I'm sure that you know what is stack and what is queue. Okay.
mm.
Queue is,
I know.
stack is LIFO. Okay.
FIFO and that is LIFO.
That is FIFO and LIFO. So
FIFO.
here. Okay.
Mm,
Okay. Now, when you insert the A here, okay, just remove it. Remove the A. Okay. Here is your
okay.
output. Write the output here. A.
Mm,
After removing a node, okay,
mm,
insert the neighbors of A.
mm.
Insert the neighbors of A. So what are the neighbors of A? Here, neighbors means,
The nearby nodes.
yeah, the adjacent nodes, adjacent
Mm.
vertices are the neighbors. So what are the adjacent vertices of A?
A,
That is
B,
B,
C,
C,
D.
and D. So you
Mm,
write B, C, and D. Okay.
mm,
Now see, you can write this thing in three different order, na?
mm,
B, C, D, or C, D, B, or
mm.
D, C, B. In any way you
Yes.
can put it, put this node inside the stack, and accordingly your
Mm,
output will be changed.
yes.
That's why I am saying that you may have different result. Okay.
Mm,
Okay. So the same thing we will do for Q also, means
mm,
BFS. So what I will do, you remove this thing. Okay. Here is the
mm.
output. You remove A, write it. Whenever you are removing a node from
Immediately you have to
either
write the
stack or
output.
queue, you immediately add it to the output. After that,
Mm.
add the neighbors of A to the queue, means B, C,
C,
and D.
D. Mm,
Okay. Now here this is the front element. You have the concept. No, sorry.
mm,
What is the front element? This is the front element, and this will be the rear element. In Q you have front
mm.
and rear element, and here this is the top element. Na?
Top and mm.
Top element.
Top element.
Okay. Now do the same process. You just remove one element from here. Which element you have to remove? In stack you have to always
In
remove the
stack D
top.
will be removed. Mm.
So write D. As soon as you write D,
Then C.
you find, no, you find the neighbors of D, because you have to put them on the stack. Na?
Okay.
Does D contain any neighbor? D have any neighbor? No.
No.
D has no neighbor. So you do not have to insert anything in the stack. Okay. Just
Mm.
do the same thing here. So which one you have to remove from this side? Q. You
Which
have to remove
here
B,
B from the queue.
because B is the front element. Okay. Then you have to
Mm.
move the front element here. Now when you are removing B, you have to insert all the
The
neighbors of
neighboring.
B.
Huh.
Okay. So what are the neighbors of B? The neighbors of B are A. A is also neighbor. A is also a neighbor. A, E, and F.
F.
But A has already been processed. Na? A is
Hmm.
already there. So we do not
Already
consider
there.
A.
Hmm.
So unprocessed or unvisited nodes will only be inserted. So E and F will be inserted here. So E and
Hmm.
F, right?
Hmm.
So this will become your rear and this is front. Okay. Uh,
Okay.
are you getting the difference?
Yes, I'm getting.
Now go with the process. So what is
Now I
the
should
next
remove C.
element? You have to remove the C. So write C here. So if you are removing C, then you have to
C.
consider which one is
Neighboring
your,
one I have to.
yeah.
Neighboring will be F.
The neighbor of C is A and F both, but A is already been processed.
Traverse.
That's why you
So
have to
F
consider
only.
F. So you put
Hmm.
F here, right?
Hmm.
F here. Okay. And that's it. Okay. Because C has no other neighbor, na? So that's it.
Hmm.
Now come here. What you have to do? You have to remove from the front.
Okay.
So
Front.
C.
C should be removed.
C should be removed. Front is shifted here. Okay. Now since you are removing C, you have to find the neighbors of C. The neighbors of C is
Hmm.
A and F. A has already been processed, so you have to
Cross.
insert F here. But F is already
If is
inserted in
already
here,
there,
so you do not
hmm,
have to insert the F
insert in.
again.
Hmm.
Next, come here. Okay, do the same operation. Remove the top element. So write
F
F.
to be removed.
Since you are removing F, you have to insert the neighbors of F.
Insert the
So what are the neighbors of F?
B is already
B and
present.
C already been there.
B is
B.
already there. E
So
should be inserted.
E should be in.
No, E is not a neighbor of F.
E is not a neighbor of F. So you
Hmm.
do not have to insert it now. Okay,
Hmm.
come here. So what you have to do? You have to remove D.
Hmm.
Just removing D. Move the front.
E will become the front.
So
Then
D
D neighbor
D
will
has no
be A,
neighbors.
C.
So we do not have to do anything here. Okay, we are
D
doing,
has A, but A is already visited, so we need not to do anything,
yeah,
right?
right, right. We are doing one operation here and one operation here. In that way we are proceeding.
Hmm.
Okay. So
Hmm.
next what you will do? You will remove B here.
B should be removed.
B is moved to the output and we have to put the neighbors of B
E.
inside this stack. What is the neighbors of B? A,
B is
F,
E.
E. All are
Hmm.
processed except E. So we
So
have to
E
put
should
A
be kept here. Hmm.
and that's all. Now come
Hmm.
here. You remove E, write E
Hmm.
here. Okay. Front will
Hmm.
move to this direction in this place. And what is
Hmm.
the neighbors of E? Neighbors of E is B, which is
B
been already processed. Okay.
already processed. F is already there.
Now next, what is the top element? This is your E.
E.
So write E here. Okay. E has no other element. So your
Hmm.
stack becomes empty. Your stacks now become
Empty.
empty. That means you got the result.
Hmm.
Okay. Now come here. Remove F. Okay. Now your front goes beyond rear. That means your queue is now empty. Now when your
Hmm.
queue is empty, you got the result. Are you getting the thing?
Hmm.
So this is the process how you have to apply or how you have to process with, means show the operations in DFS or BFS. You have to show the steps using stack and queue accordingly. Okay. Now just follow one two thing
Here
I
I
have
had
told.
little one doubt.
Hmm.
See now when we are at F, which will be pointing rear and front? Front will be F only. Rear would have been pointing to what?
Which one?
At the position where F was there, no, here in the queue.
Here in the queue.
In the queue, only the front is at F now.
Front is
What
at
will
F.
be the rear will be which position? Rear will
Rear,
be
rear in this position because rear was last updated when the neighbors were inserted.
hmm
Okay, in queue, if you remember, rear is updated only when you are inserting inside the queue, no?
Hmm.
But here we are deleting from the queue. So when you are deleting from the queue, your front pointer will be updated. When you are
The rear
inserting in
will be the
queue,
same thing.
rear will be updated. Okay. So rear here R was updated last time when the neighbors were added. I think the neighbors
Hmm.
of C were added. C or B were added over there. Okay. So that was the last time when rear were updated.
Hmm.
Else, whenever you are deleting, you are updating only front, not the rear.
Okay.
Okay.
Hmm.
Okay. Just a second. Hello.
Ah.
Huh. See here. See here. What is this?
Hmm.
A, B, C, D. So can I say that A, B, C, D, E, F? It is going in this direction. B, C, D, then E, F. Okay. Can I say that?
Hmm.
A, B, C, D. If you move along these nodes, then
Hmm.
I can draw this path. Na?
Hmm.
So what is this? This is the breadth of the or the width of the graph. If
Okay.
you draw the
Okay.
graph in this way, so this
Hmm.
easily is you can identify that this is the width of the graph. Okay,
Yes.
that's why it is called breadth first search.
Breadth first
Means
search.
you have to
Okay.
move along the breadth, so you can easily justify whether your output is right or wrong. Okay.
Correct.
Now what is this? See here, A D C. So A A D, we come to D. After that, we have to go
Then
to
C.
C. So to move to C, there is no direct connection between D and C.
Hmm.
Na? So to move to C, we have to visit to A. Then we have to come here. Okay.
Mm-hmm.
So when we are at C, after C, we have to move to what? F.
Yeah.
F. So we are digging deep inside. Na? We are digging deep
Hmm.
inside. Okay. So when you are F, you are going to B.
Hmm.
When you are B, you are going to
You're going to
E.
E.
That means the basic difference between these two is that when you are at a node in BFS, you have to
Hmm.
visit all the neighbors of that node after visiting that node. Okay.
Hmm.
So when you are at A, after visiting A, you are visiting all the neighbors of A. See here, all the neighbors of A.
Hmm.
Now, when you are at B, you are visiting all the neighbors of B. So, when you are B, you are visiting all the neighbors E and F, U and F. Okay, this is breadth first search. But in case of depth first search, when you are at neighbor, when you are at node, so you will visit one neighbor of that node. Now, when
Hmm.
you move to that node, you will visit one again neighbor of that node. Means you are
Okay.
finding a neighbor of that node.
Hmm.
Then again neighbor of neighbor. In that
Hmm.
way you have to move through the graph until you comes to a dead end. If you comes to a dead end, then you have to move to the backward direction. Are you getting the thing? Like that.
Hmm.
D. When we come here D, we cannot move from D anywhere because D has no other connection with any other
Hmm.
nodes in the graph. So we have to move in the back direction, back to the parent. Then again means back to the mm, uh, previous node. Then you have to move
Hmm.
along with another path. So that is depth first search, and that is breadth first search. Breadth first search will move in this way horizontally, and that is vertically, you can say. Okay.
Hmm.
all other are same. So if you have to write an algorithm for that, then how will you do that? If you remember the process, then you can write up the algorithm from your own. You can write in that way. Say, I'm just saying, I'm not writing, it will take much time. Okay.
Mm,
Say, take a stack. Okay. Visit to the root. Let V is the node. Okay. V is equal to root. Okay.
mm,
Means make a list of all nodes A, B, C, D, E. Okay. So
mm,
from that list, I am taking one node. Okay. Visit that node and output that node. After that, push the neighbors, one neighbor of means push all the neighbors of V. So what
mm.
is the neighbors of what are the neighbors of A,
B,
B,
C,
C,
D.
D? So we are pushing B, C, D. Okay, and this will repeated. This will be repeated. Then pop one node from stack and push all the neighbors of that node into the stack again and go on. Simply you write these full lines. That is your DFS algorithm. Okay.
Mm,
For VFS algorithm, make a list of all nodes of the graph. Take one node from the list and insert it into queue. Okay. Remove the node from queue means dequeue means process queue delete. So queue delete will give you a node from the front position of the queue from the queue.
mm,
Visit the node means output the node. After that, insert all the neighbors of that node into the queue again and
mm.
repeat this process. This is your breadth first search. Okay.
Okay.
Okay. So this was your DFS and BFS. These are two important topic which they may give algo and code
Mm,
as well. Okay. Uh, and even if they do not ask you to solve the problem like that, suppose they are giving write an algo or code, to me it
mm,
is always better to give a small example of this type of working. Okay, so let this is a graph and this is the DFS for that graph. That is always better from exam point of view. Okay,
mm.
so that was your DFS BFS. After that, breadth first search. Next, you have why they put long code like that. Are they going to give these kinds of code in exam?
That's what I was also wondering. But this they had not given like
So they
compared
have
to
filled up the
last time
pages
also.
with the codes. Okay.
There are so many codes and that too lengthy, lengthy codes.
Hmm.
Like how
What is the necessity of putting all those codes? Topological sort. Yeah. This topological sort is mm, suitable for giving operations, not not the algorithm, because algorithm part is very 2 3 lines of algorithm will be there. Okay, so it is better to have a problem solving practice on that. So this graph, although I do not like this graph to demonstrate topological sort because it has some constraint. uh, if I
mm,
can take another graph,
yeah.
just a minute. Topological sort, this is
Mm,
important in terms of operation. Okay,
mm,
topological sort is basically if you have a graph. Okay, say I am taking a graph like that. Say 0, say 1, 2, two, three, four, and five. From 2 to 5 there will be a edge, 2 to 3, and 3 to 4, 5, 1 to 3, 0 to 3. So this is a graph. Okay.
Mm.
Topological sort of a graph means you have to find a path. Okay.
Mm.
So that
Mm.
all the edges, all the means those
It just
vertices,
sorry. Okay, what is this?
yeah, all the vertices will be there in a
Mm.
sequential way. Okay, your aim
Mm.
is to find a set of vertices, okay,
Mm.
with a according to a particular process, and that is your topological sort. Okay,
Means
topological
all the
ordering.
vertices will be
See,
in the
this is
serial.
basically an ordering. Okay, ordering of all the vertices. Ordering of all the vertices. See here, this is, I think this is the order, huh? Topological order. Okay,
Mm.
this is, see, in the DFS and VFS, you also got an order. What is DFS and
Mm.
VFS? Those are some orders of
Bread. Mm.
arranging the means
Mm.
traversing throughout the graph. Na? So this is
Mm.
another order of finding another order of the vertices.
Mm.
Okay, so how to find that? How to find that kind of order? Okay, see here it is very
Mm.
interesting. So you know what is in degree and what is out degree, na?
A little bit need to be.
No, in degree means the in degree of this one, this one node is one
Mm.
because only one incoming
Okay,
edges
I
are
got
there.
to know.
Out degree is,
I remembered now.
remember.
Out degree will be 2 for this.
Hmm. Okay, so what you have to do, you have to find the in degree. You
Mm.
have to find the in degree of each and every vertex in an array. I am not writing all those details. I'm just showing you the process. Okay, so it is better that you find an array like that, and inside that array you store all the in degrees. Okay, but see the process. So what will be the in degree of this node?
1 second, sir.
Hmm.
Only 1 second. Wait a minute. Huh. Sorry, I'm back.
Okay, see here, what will be the in degree of this node?
In degree is 0.
0. Okay, what will be the in degree of this one?
1 will be 1.
1. What will be the in degree of this one?
1.
You have to follow the direction, na? This is 1.
Huh.
What will be the in degree of 3? 1,
3
2,
will be
3.
1, 2, 3.
3. What will be the in degree of this one?
That will be
2.
2.
What will be the in degree of this one? That will be 2. Okay.
Mm.
Now you have to sort all the vertices according to the in degree. Okay, and you have to consider the in degree that comes with 0. You have to select the
Mm.
vertex that comes with in degree 0. Now
Mm.
currently we have one vertex only that comes with in degree 0, na?
Mm.
So we consider it 0. So in output, what you have to write? We have to write 0. Okay.
Mm. Mm.
When you are selecting this 0, that means you
Mm.
select this 0. Okay. then what you have to do, you have to decrease the integrity of its adjacent vertices. Okay, of its
Mm.
adjacent vertices. So what are the adjacent vertices of 0?
0 is 1 and 3.
So you decrement that in degree by 1. So what will be the in degree? That will be 0. And
0.
what will be the in degree?
Decrease the in degrees of
By
neighboring
1.
rest.
Hmm. By 1. You have to decrease by 1.
Uh,
So it will be 2. Okay.
uh,
Actually, it means, if you wonder why I am doing this thing,
mm,
it means actually, see, you have already selected the 0, no?
uh,
You have already selected 0. So you
mm.
have to remove, you send that 0 in the output, na? So
I
you have
sent
to
it.
remove the 0 node from here, from this graph.
Mm, mm.
So if you remove that 0 node from this graph, so what will be the integrity of this one? This will be 0.
This is 0.
And what
Mm,
will be the integrity of this 3? This is 1 and 2 simply.
mm,
Okay. So in exam, you can show in this way, okay,
mm,
that I am showing, or you can go by removing the vertices from the graph. Okay.
mm.
So the process will continue until no vertex is there in the graph, or the
Last vertices will have the in degree
0.
as 0.
Okay. Now you have to select the vertex with index 0. Which vertex you will select? Just only one vertex is in degree with 0. So 1. So you are selecting 1, right? So I'm
Mm.
writing 1 here. So if you select this one vertex, so what are the adjacent vertex? 2 and 3.
2 and
You
3.
decrement this by 0, by 1.
2 becomes
2
0
become
and this will be 1. 3
1.
will be 1 again.
Okay.
So
That means,
now 2 will be output.
it means that you are removing this one. Okay.
Mm,
So you are removing this one. I'm showing you in both way. So now the graph
mm,
is like that because already 0 and 1 has been taken.
mm,
Now what you have to select? Which node you have to select? You have to select this one. If you
2.
have multiple
Mm,
nodes with 0, then you can select any one. Okay.
mm,
So you have to select 2. So
mm,
you are selecting 2 because it is integrity with 0.
mm,
Now you have to decrease the integrity of the adjacent vertices. So it will be
mm,
0, it will be 1, and it will also be 1. Right?
mm.
So it means that you are deleting these
3.
things like that. Okay.
Mm.
Now what you will do?
Then 3 is having the in degree as
3.
0.
So you
We'll
are
take
taking
3
3.
and decreasing 4 to
This will be
0
0.
and
This will not be
uh,
changed.
that will not be changed.
Okay.
4 will be like that. 4
Hmm.
only will become 0.
So you are removing this one too. Removing
Then
this one.
4 we will remove.
Then you are
Then 5
selecting 4. So
that
write
time
4
5 will.
here. So
Hmm.
that will be 0. So so the integrity of every vertices has become 0. Now select 5 only. 5. Tell me, this is the way how topological, this is an order, topological order. Okay.
Topological order is nothing but ascending order.
It's not ascending order. It depends on the graph, na? It depends on the graph. If
No,
you
but
do,
the graph is also will be taken in a ascending order only,
no, no,
na?
no, no,
Means it
no,
is
no, no, no. That is not true. Okay. If you, if I remove some edges from here, if I
means
introduce,
sequential order. You told no, all the vertices are numbered sequentially.
no, it's not sequential order. Order is always not sequential. Means the ascending or descending. Sequential, it may be sequential. Okay. So it is
Hmm.
always not like that, कि ascending or descending. Suppose five persons are there and you are making an order, the shorter person, then a longer person, then again a shorter person,
Mm-hmm.
then again a longer person. So this is also an order. And this is not like that. Okay, shorter person will come first, then again the longer person. So this is your ascending order, and this is not ascending order. This is neither descending order. This is another order. Okay. So topological sort give you some order according to this rule. Okay.
It is based on the neighboring nodes.
It is based on the in degree.
That's what, in degree of
Hmm,
neighboring
hmm,
nodes.
hmm, hmm. So simply this is your ascending, this is your topological sort. You will be provided with a graph,
Hmm.
and you will be asked, maybe the graph will be become more complicated. So you will be asked to produce a topological order of that graph.
Output what it.
Okay.
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 This they have given, I think, in the MCQ. This was there in CA3.
Mm, yeah.
I think something they had asked with related to topological order.
Yeah, maybe A B C D. They have
Mm.
given a B A C or something with A B C D as
Mm.
as a. Okay,
It's
so
very
what
interesting.
is? Yeah, these are
Oh,
very interesting, but unfortunately, we have very less time, and due to our medical reasons, both you and me, we were not able to continue in that way we started. Okay.
yeah. The way we started could not catch up.
Mm-hmm. Next, you have generating combinatorial objects. These are very silly things. I don't know how they will give these things, but they may ask also to produce a combinatorial objects. Now, what is combinatorial object? What is that? Okay. Now, what is combinatorial object? I was going to generate combinatorial objects. What is combinatorial? अरे बाप रे. What is combinatorial objects? Means you have to make the combinations. Okay. So what they will give you. Hello.
I'm
Uh,
there.
I'm very much. I'm not sure about my laptop Wi-Fi. Okay, it is showing some disturbance. Okay, so one, two, three, they will give you a set like that, and they may
Mm.
ask you to show all the
Mm.
combinations of these numbers. Okay,
Mm.
Shashiji, give me 1 minute. I am just adding my adapter to the charger
Okay, okay.
laptop. Okay.
Okay.
Hello.
I'm here.
Mhm. Okay, so how the combination can be done in an algorithmic way? Uh,
Mm.
we can we can do the combination. Okay, tell me how many combination will be there for this set?
Three, three is a nine.
No, no, not nine. How many numbers are there? That is three.
Three, huh?
So not
Three
combination,
to the
permutation. Okay, means
Okay.
how many permutations can be performed? It will be
Factorial.
factorial 3, that means
3
6.
factorial. 3
6
to the
will be there.
6. Hmm.
Okay. So how to generate it in an algorithmic way? Okay.
Hmm.
So this is the process that they are saying. But actually, there are two process. One is your normal sequential integers. This process.
Hmm.
Okay. And another is your this one Johnson-trotter algorithm. No, Johnson-trotter algorithm has more chance to be given,
Hmm.
but this will also I am trying to demonstrate it. Okay,
Hmm.
so here is your set 1, 2, 3. Consider first number 1. Okay,
Hmm.
now take the second number.
Hmm.
Uh, what you will do? Just a minute. What you will do? You will take the second number 2, na?
Hmm.
So what you will do? This is first step. And next
Hmm.
step, you will add 2 to the previous number at
Hmm.
the right hand side.
Hmm.
First, you have to go to the right hand side.
Hmm.
Next, you will go to the left hand side. That means 1, 2 will be there in this way. Okay.
Hmm.
Are you getting the thing?
Yes, yes, I got it.
First, you have to go to the uh, left hand side, a right hand
Ah,
side. Then you have to go
ah,
to the right hand side.
ah,
Till now, we have considered 1 and 2, right?
ah.
Now you consider the
Now 3.
3. Okay.
The second,
So
third step it will come.
for both the set,
Hmm.
you have to do first right,
Hmm.
then left. Okay. So
Hmm.
take this one. Okay, I am taking this one.
Hmm. Hmm.
So
1,
1,
2, 3.
2, 3 will be there.
Hmm. Hmm.
Then what you will do? From right to left.
Hmm.
So 1,
1, 3,
3,
2.
2, then
That's it.
3, 1,
Oh,
2. So from right to left now.
okay. Then 3, 2, 1.
Then no, 3 to
3.
1, 3 to 1 will not come here. See, these are all for this set. Okay. Uh, just a minute. Just a minute. Just a minute.
1, 2, 3.
See, I am inserting 3.
Hmm.
কিরে
Hmm.
কিছু বলবি আচ্ছা so 1 2 3 I am inserting 3
Hmm.
1 2 at the right side. Okay,
Hmm.
then what I will do, I will
Towards
move
left.
these 3 from right to left.
Hmm.
Okay,
Hmm. Hmm.
so right to left means 1 3 2, right? Then
Hmm.
again I will move these 3 to the rightmost side. 3 1 2. Now you are getting.
Okay.
Now here you have to move from left to right. Okay, so
Okay.
you put 3 2
2,
1,
1.
then
Then 2, 3,
2
1.
3 1. See, 3 is moving towards the right, left to
Hmm.
right. Then
Now 1 will
3
be moved.
2 1 3, and these are the combinations. These are the permutations of 1 2 3. Tell me if you are getting the thing.
This last combination only, why not others only? This I'm little bit confused.
Which one?
The last combination we wrote, no?
Last combination means?
This one. 3, 1, 2, and 2, 1, 3. Can you please come again with this?
Okay.
In the last step, the third set.
Just
First one
one
I
minute.
got
Just
it.
1 minute. This is the first one. This is the first number.
Uh,
So you
uh,
have to take the second number and first you have
2, 1
to
is to the
write
right and 1 is to
right,
the
one is
left.
to the left. Okay. After
This is
that,
done.
you have to consider each of them and
Mm,
process right to left, then left to
mm,
right. So
okay.
this for this we will select right to left because this is the first one.
Mm,
Next for this we will select for left to right.
mm,
Okay. So which one? This 3 one.
mm,
So we have to insert 3 here from right
mm,
to left. Insert 3 from right to left, and
mm.
here insert 3 from left to right.
Left to right.
So if you insert 3 with 1 2, then where you have to
1,
put?
2,
You have
3,
to
I
put
will get.
3 here
Mm,
from right,
mm,
then move
mm.
from right to left. Move from right to left. So 1 3 will be there, then 2. Okay. Then again 3 will be shifted one more time. 3 1 2. Okay. Is it
Just a
okay?
second. Just a second. I'm just a number. 3 is done. Again, we are taking between the second digit till the last time. Okay. Got it.
Okay.
Mm,
Now 2 1, where you have to put the 3 in the left side.
mm,
So from left to right.
mm.
So 3 will move in the right direction. So 2
Mm.
3 1.
3, 1.
3 will again move
Then
there.
it will be
So 2 1 and 3 will be
1,
there.
3.
So these are the combinations. These are the permutations. See here, one, two,
Okay.
three, 1 2 every six item are there. Okay.
Mm.
Now suppose you have one more item 4. If you have one more item in the
In
set,
list. Mm.
then you have to consider each of them from right to left. Okay.
Mm.
Then left to right,
Mm.
right to left, left to right, right to left, left to right, like that. Once you are doing right to left, you will always have to start with right to left, then right to right, right to left, left to right. Simple.
Okay.
So this is your algorithm for generating combinatorial objects, means to
Mm.
find the permutations of the elements within a set. Okay,
Mm.
tell me if it is okay.
Yes,
Then
this
you
is
have more complex algorithm,
topics.
James Trotter.
This was combinatorial. In that, the first method is
Sorry,
this is the one what we saw, no? Johnson-trotter or
this is not
that.
Johnson-Trotter. Johnson-Trotter I am demonstrating now.
Okay. This one, what we did is the name of that algorithm is
General algorithm for generating combinatorial objects.
okay, general algorithm.
It's a general algorithm. They have not
Mhm.
specified any name for that. This is a general algorithm for generating combinatorial object. Next we have Johnson-Trotter. Okay. Now this Johnson-Trotter algorithm, you have
Mm.
to remember, you have to know something
Mm-hmm.
called mobile numbers. Now what is mobile number? Okay.
Mm-hmm.
So Johnson-Trotter is a separate algorithm Generating Java program. Generating combinatorial objects using Jhonson-trotter algorithm. Johnson-trotter algorithm. Johnson-trotter algorithm. It is doing the same thing, but in some different manner.
Mm.
Okay. So
Mm.
one, two, three. This is the
3.
set. Okay.
Mm.
This is the set. So
Mm.
I'm taking less number in the set. Otherwise,
Yes,
the time
otherwise
will
it
take.
becomes too lengthy.
So first you can create a table for that. Okay, I can provide you that table also, but
Mm.
just see it in that way right now. Say 1, 2, 3. You
Mm.
write the first combination 1, 2,
Mm.
3. Okay, while I am saying combination, you can take it as a permutation also. Okay,
Mm.
so both terms are same here. Okay,
Mm.
so take this permutation. Okay,
Mm.
this is the initial permutation. Okay, this
Mm.
is the initial permutation, and when I am considering this permutation, I put a tick here. Okay,
Mm.
I just put a tick here. So this is one permutation I will take. Okay,
Mm.
okay. Now put this kind of arrow in
Mm.
front over the
Each element.
numbers, each and every
Mm.
integer. Okay,
Mm.
so this direction can be like this. Okay, from left to right, from right to left. Okay,
Mm.
initially you have to give in the right direction for the first one. Okay,
Mm.
now here you have a concept called mobile component.
Mm.
Now what is mobile component? Mobile component is such a component, means such a number in the
Mm.
permutation
Mm.
which is for which the direction is from
Mm.
higher to lower number.
Mm-hmm.
So which one is your mobile component here?
3.
2 as well,
Mm. Correct.
because 2 is pointing from 2 to 1, from higher to lower. Okay,
Mm.
so it is a mobile component. It is a mobile component. I'm
Mm.
putting a dot here. 3 is also a mobile component because 3 is pointing to 2.
Mm.
Now first step. Now your first step. First of all, you have to
Mm.
identify the mobile components. You
Mm.
can say the second step is to find the largest mobile component in the permutation. So which one is
Mm.
your largest mobile component?
3.
3, right?
Mm.
Okay. So if you find the largest mobile component, then
Mm.
what you will do?
We'll have to
You
move
have
from.
to swap that
Mm.
mobile component with the number that it is pointing to, means with the adjacent
Mm.
number. So what will be your next? That will be your 1.
Mm.
Next you will have 3, then you will have 2. You are swapping. Okay,
Hello.
hello.
This one swapping will happen from the highest to the adjacent number.
What?
The mobile component, we're finding the largest component. Now that time we swap between which values?
You have to find the largest mobile component.
Mm.
The
After that,
largest mobile component, when you are finding the largest mobile component, then you have to swap it
swap it with.
with the number that it is pointing to. Okay, means if 3 is pointing to 2, then
Mm.
you are swapping between 2 and 3. If 3 will point to 4, then you have to,
Mm.
means some other number. Suppose it has some
Okay.
suppose it has some 1 here. Okay, 1.
Okay, got it. Mm.
Suppose 1 here. Okay,
Mm.
since 3 will not be, 3 is a mobile component, but
Mm.
To which it is related? It is related
To
with 2.
two.
It is not related
Mm.
with 1, because the direction of 3 is from 3 to 2, right? Are you getting the thing?
Got it now.
So mobile component will be the highest mobile
Pointing to
component.
the
The largest mobile
highest
component will
mobile
be
com.
swapped.
Oh.
So when you swap the mobile component, you consider
Mm.
that as a permutation.
Mm.
Okay.
Mm.
One more thing you have to find after swapping, if
Mm.
there is any mobile component, if there is any not mobile component, if there is
Mm.
any value which
Mm.
has the larger number than the mobile component, you
Mm.
have to reverse the direction.
Okay.
You have to reverse the direction. Suppose after swapping this, suppose
Mm.
here there is a 4. Okay, so what you have to do, you have to opposite the direction after swapping.
Mm.
It will be done
Okay.
just after swapping. Okay,
Okay.
but in this case there is no larger
No.
number than
Mm.
3, so we kept with it.
Mm.
Okay, now this process will be what? This process will be repeated. Now again
Mm.
find the mobile component from, you have to find the mobile component from the latest combination,
Mm.
latest permutation. So which one is your mobile component? Is 2 mobile component? Is it a mobile
No.
component anymore?
No. No. No.
No,
No.
it is not
It is
mobile
not a
component.
mobile component.
Now the mobile component is only 3.
Only three.
So now do the same process. 3 will be interchanged with which?
Pointing with one and
So it
three.
will be interchanging with 1, not with 2,
Two.
right? So 3 will be there, then 1 will be there, then
Two
2
will be.
is there. So consider this again as a permutation. Okay. Now after that, do you have any mobile component left?
Mm-hmm. No, we
You,
have no two. We have
yeah, you have two. You have two mobile component because 2 is larger and it is pointing
then
to
one.
1.
One.
So do the interchange. So
Three
first,
will remain as it
no, no,
is.
no. First you make the interchange. Okay. So make 2 here and 1 here, right?
Hmm.
Now you find, is there any number in the last permutation which is more than this mobile component? Yes, that is 3.
Hmm.
So what you have to do? You have to
Change the
reverse the
date.
direction
Hmm.
in that way. See here, the direction is changed.
Hmm.
Now is there any mobile component left? Yes, it is 3.
Yes, three is a mobile
3 is a
component.
mobile component. Then do the same process. Oh, consider this one as a, this one as a
Permutation.
1 permutation. So move 3.
Hmm.
So 2 will be there, 3 will be there, and 1 will be here. Okay, this is an amazing technique. Just like the play of a child, na? It's like childish, but it is an algorithm. You
Hmm.
need 2, 3 loops to perform this thing, and all the permutations will be readily available in your hand. Okay, so consider this as 1 permutation, and
Hmm.
again, this is a mobile component,
Three will be the mobile component, but
right?
again it is
You have,
greater than the one,
hmm.
but direction is always pointing.
So 1 will be there, and 3 is there. Now see, is there any mobile component left? Is there any mobile component left?
One
2
second.
is pointing to something else. So 2 is not a
Hmm.
mobile component. 1 is pointing to 2. 1 is not mobile component because 1 is less than 2.
Hmm.
3 is pointing in other direction. So there is
Hmm.
no mobile component left. Hence we
Hmm.
have completed.
Hmm.
Now count how many combinations you found. One,
One, two,
2,
three, four, 5,
3,
and last one is
4,
6.
5. No, this one. This is your
Huh.
one, na?
One is
This is
initial.
2,
Huh.
3,
2, 3,
4,
4, 5,
5, and 6.
6.
So these are
Huh.
the six possible permutations that you can have with this set.
Set. Okay.
So this is your Johnson-trotter algorithm, which is more
Hmm.
important than this one.
Okay.
Okay. See,
Hmm.
looking at this algorithm
Hmm.
means doing by others,
Hmm.
it will be easier. Okay. It will
Hmm.
appear to be easier, but you have to
Hmm.
practice. Otherwise, you cannot
Hmm.
perform that thing. It's same thing, just like the mathematical problems we did in the last semester.
Hmm.
Okay, you have to do it in your own hand. Anyway, so that is your Johnson Trotter.
Hmm.
Then advantage, disadvantage. Okay, we have completed this part.
Hmm.
Only the sixth unit we have completed.
Hmm.
Should we do more?
We can one more. We can, I think, no,
Yeah,
if possible. Like if your time permits.
yeah, no problem.
Okay.
Okay, let's move to the
After 6, the next unit is 9.
9. Okay, it's already 1.5 hour, so better just stop this recording and
Recording.
download
And
it, then again
hmm.
start new recording. Otherwise,
Okay.
if it go,
Go on means
then
yes.
everything will gone. You will have no reference. Okay, so
Okay.
just let me stop it.